Welcome to another tutorial video. This time around, we're going to look at how you can quickly approximate the internal rate of return, or IRR, in a leveraged buyout scenario. So here is the typical question we get on this topic. Can you quickly approximate the IRR of a leveraged buyout? I don't want to set up an entire model to calculate it. Also, don't you have to know this so you can answer paper LBO model questions in case studies and check your work in modeling tests? And the answer to both those questions is yes. The short answer on the first question is that you can sort of approximate IRR, but certain conditions have to be true for these tricks to work. The longer answer is that if you have a simple upfront investment and exit with no cash flows in between, yes, there are some rules and rules of thumb you can use to approximate IRR. If it's something other than that, so it's not a simple M&A exit, maybe the private equity firm conducts an initial public offering, an IPO, and they sell off their stake gradually, that is going to throw off the math, and then this method will no longer work. If there are dividends in between, or there's a dividend recap, or there are asset sales or acquisitions, or anything else unusual, the rules are going to be distorted, and the math and the simple trick will no longer work. With that out of the way, though, let's jump into the main part of this lesson and learn what these rules are and then how to apply them. So the way IRR is officially defined is that it's the discount rate at which the NPV of cash flows from an investment equals zero. So essentially you take the future cash flows from the investment, you discount them back to their present value, and then you try to find the discount rate at which the present value equals whatever you initially invested in the company or asset or whatever else it is. Now in real life, you can't solve this with a simple formula. You have to use trial and error to solve it. So in Excel, the program will guess a number for the IRR and then go higher or lower and then try again until it has a reasonably close solution. What it means intuitively is that it's the effective compounded interest rate. So if you invest $100 today and then you earn 10% to get 110, and then you earn 10% to get 121, let's say that you end up with 150 after 5 years. And we know in advance here that the interest rate is 10%, but if we didn't know that, what would the interest rate to get that 150, starting with 100, actually be? And that's what the IRR tells you. As an example of this, if we open up a simple LBO model, we can see here that the internal rate of return is around 43% in this particular model. We know that we invest 132 in the beginning, and we get back 385 at the end. So what the IRR is telling us is if we start with this 132 and we earn 43% on our money each year, compounded over time, by the end, we get to the 385. And the IRR function in Excel solves for this and tells us the rate that lets us get to this 385 by the end of the period. So normally you calculate this in Excel and you leave it at that, but there are certain scenarios where you want to approximate it, either because it comes up in an interview question or because you want to check your work and see which direction you should go in before you go through a full case study and model. To approximate it, you can look at the money and money multiple and the investment period and then memorize a few simple rules of thumb around this. The money on money multiple is just how much you get back, so the 385 here, divided by how much you put in, the 132 in this case. And you can just do the math in your head and see it is roughly a 3x multiple. In more precise terms, it's about 2.9x, but you can just look at the numbers and tell that it is roughly tripling your money over 3 years. The way to think about this intuitively is the following. If you double your money in 2 years, what is the IRR? And to answer this question, you can start by thinking about what happens when you double your money in 1 year, which is a 100% IRR. So you invest 100, you get back 200 the next year, you've gotten 100% of what you've initially invested. So if it takes 2 years, that is roughly a 50% return each year. So you invest 100, it takes you 2 years to get back the 200. Roughly speaking, you have to earn about 50% per year to get back that 200 at the end of 2 years. Now, of course, it's not exactly a 50% return each year because of the compounding effect. So it's actually less than 50%. And if you calculate this yourself in Excel, it comes out to around 40%. Once again, let's look at a simple example of that and say 100 and then we have year 1 and then year 2 right here. And if we run the IRR in this scenario, it comes out to just over 40%. So the idea here is that for these double your money scenarios where you get back twice what you put in, you take 100%, which represents the IRR if this only takes 1 year, and then you divide it by the number of years in the period. So 100% divided by 3 year is 33%. So if it takes you 3 years to double your money, that is 33%. But then the IRR is going to be less than this because of that compounding effect. Usually for these double your money scenarios in short time frames, it's about 75 to 80% of this value. So in this scenario where it takes 3 years to double your money, you can approximate the IRR as about 25%, which is roughly 75% times the 33%. And if you actually calculate this in Excel, it does come out to around 25 or 26%. So that's the intuition behind it. Take 100%, divide by the number of years, and then the IRR will be about 75 to 80% of that. Here's the full set of rules and rules of thumb. If you double your money in 1 year, it's a 100% IRR. 2 years, it's 40%. 100% divided by 2 is 50%, and then make the IRR less than that. 3 years, it's about 25%. 4 years, once again, 100% divided by 4 is 25%, and then you make the IRR less than that, so it's about 20%. 5 years, same idea, it's now about 15%. Now, for scenarios where you triple your money, the equation changes a little bit. These are less common, but it's good to know some of these rules as well. If you triple your money in 3 years, it's about a 45% IRR. And then if you triple your money in 5 years, it's about a 25% IRR. With these scenarios, you're essentially getting 200% back. So you can take 200%, divide by the number of years, and then make it less than that. In this case, it's going to be not 75 to 80%. It's going to be more like 60 or 65% of that number, which explains why these IRRs are lower than what you'd expect if you just took 200% and divided by the number of years. So those are the rules of thumb. The most important ones are doubling your money in 3 years and 5 years, and then tripling your money in 5 years. If you memorize those, you can answer many of these interview questions very, very simply. So now let's go into part 2 and look at a simple example. This one goes back to one of the case studies that we made available, an assessment center LBO modeling test. You can go back and look at this yourself, but I'm just going to focus on some of the numbers and intuition here. So we're buying a company for around 7x EBITDA. The company's current EBITDA is 50 million euros. So our purchase enterprise value is about 350 million euros. Now, the case study assumptions give us the debt to EBITDA. Altogether, it adds up to around 4.5x debt to EBITDA. So we've reflected that in Excel. What this means is that we contribute about 2.5x equity to this deal. This gives you about 125 million for the equity contribution to this deal. Now, the year 3 EBITDA, of course, you can calculate it yourself in Excel, but if you just go from the assumptions, we know that revenue is growing by about 10%. The EBITDA margin is staying about the same. If revenue is growing by 10% per year over 3 years, we can say that EBITDA will go from 50 million to some number higher than that. It's going to be more than 30% higher because of the compounding effect. On the other hand, it's probably not going to be as high as 50% higher. So we can approximate that and say that EBITDA might be around 70 million by year 3. The case study gives us the exit multiple of 8x. So we know the equity contribution in the beginning. We also know the exit enterprise value. Now, to figure out the equity at the end, we need to subtract the debt balance outstanding at that point. The case study instructions here tell us that we have 3 term loans. We have a second lien loan and then a paid-in-kind loan. The second lien and paid-in-kind loans don't amortize at all. They have bullet maturity. But then the term loans all amortize equally over 5 years. So if you think about this, all these are 1x EBITDA. The company has about 50 million in EBITDA right now. They're amortized over 5 years. So what this means is that 30 million of term loan A will amortize, 30 million of term loan B, and then 30 million of term loan C. Altogether, that adds up to about 90 million in amortization, which means that at the end, if we used 225 million of debt, we amortize 90 million, we have about 135 million of debt left over at the end. So our exit proceeds will be 70 million times 8 minus the 135 million. You subtract those and you get to 425 million for the exit proceeds at the end. And then if you think about the math here, 425 million divided by 125 million is just over 3x. And so we'd approximate the IRR as being about 45% or just over 45% because the private equity firm earned more than 3 times its money back in just 3 years. Now, if you go into Excel and look at this scenario, you'll see that the actual IRR is only around 43%. So what explains this difference? Well, first off, we ignored the transaction fees, which the case study document outlined. These may seem small, but the significance is that they increase the amount of investor equity required. The other thing is that we ignored paid-in-kind interest. So it's not quite accurate to say that we just end up with 90 million of debt less at the very end. If you actually look at this and you look at the total debt numbers, because of the fact that the paid-in-kind loan increases each year, we take our total debt, we subtract our ending balance, and we only end up about 78 million lower at the end. And then finally, the year 3 EBITDA figure was an approximation. It wasn't the exact number, so we were also off in that sense. And if you look at this, you'll see that the actual EBITDA was around 67 million, not 70 million. So we are a little bit off, but this is still pretty good for a 60-second estimate. Now let's go into part 3 and look at a more complex example here for a 3-hour private equity case study. For this one, I pulled an example from an oil field services company. If you want to see the full case study outline, I have some screenshots here of it. You can see that we're given 3.5 hours. They call this company Robinhood, and it provides services for exploration and production companies. We get their sales and EBITDA, and then we get some instructions around the purchase price, the purchase multiple, and then some of the operating assumptions in the model. Now, in this case, we are given some detailed numbers to use, and also we were given a partially completed Excel file. So the temptation in this case would be to jump in right away and start entering numbers, but we would urge you to step back a little bit and think before you do this. Remember that the purpose of these case studies and modeling tests is to make an investment recommendation. If you know in advance which way you should be leaning, it helps you a lot because it helps you check your model and it helps you move toward that recommendation in the end. If you run out of time, it also helps to know the numbers and what you should recommend. So we suggest doing a quick check of the numbers first. Now we are given the purchase price here. They say 100 million and we have fees and expenses of 3 million, purchase price of 5.5x the EBITDA in the year before the transaction takes place. So we have some of those baseline numbers. And then further on in this case study, we have this information about 18 million of mezzanine. The company's EBITDA was 18 million, so it's about 1x. They're being very vague about the rest of the transaction structure. They're just saying a revolver and then term loan A split that is appropriate and based on market rates. That's quite vague, but we can just assume 3x for those. It is quite uncommon to see term loans at more than 2 or 3x EBITDA, so we'll just make a simple assumption and say 3x for now. So in total, we have about 4x EBITDA for the leverage, which means that we need equity of about 1.5x. Because remember, our purchase price is 5.5x EBITDA. 1.5x EBITDA is 27 million. Of course, we also have fees and expenses of 3 million, so we can round this up and say our equity required is 30 million here. We also get this information that selling shareholders have agreed to roll 5 million of their equity into the new company. So in reality, the PE contribution here will be about 25 million. We have a rollover of 5 million, 30 million of total equity that's required, so the PE firm ends up owning roughly 80% of the company after the transaction. Technically 83%, but we're just rounding it to 80 here. So we know the upfront equity contribution, and now we need to figure out how much the private equity firm gets back at the end. One part of that is getting the proper multiple. They tell us right here to use 6x for the EBITDA exit multiple. So that's easy. We can just estimate the final year EBITDA and then use that 6x multiple. But the other part of it is figuring out the amount of debt remaining at this point. From the assumptions, they're saying that term loan A amortizes over 3 years and then the mezzanine stays outstanding. So at the very end, we know that we have at least 18 million of that mezzanine loan outstanding. Now for the rest, it seems like term loan A will go away completely, but remember, the company only has around 18 million of EBITDA right now. We're also assuming that the term loan represents around 3x EBITDA, so around 18 million amortizes each year. Now, if the company only has 18 million EBITDA, they cannot possibly repay 18 million each year. So they have to draw on the revolver and borrow some additional funds. We don't know exactly how much it'll be, but we can estimate this very roughly and say that they'll probably have around 40 million of debt left over at the end. They're not going to be able to delever completely because of the fact that they won't be able to repay the full 18 million each year. So we're just approximating this and saying about 40 million of debt left over at the end. Now, for the revenue here, we're given a few assumptions. They say that sales should decline by 10% and 5%, and then after that, they should grow by about 10% annually. What this means is that we will probably end up with some number that is higher, but not as high as we might expect because of those declines in the beginning. We can estimate this and say that we'll end up around 15% higher. Normally, if we had 10% growth, we would end up quite a bit higher over 3 years, but we have those declines in the beginning, and so we're starting from a much lower base. We're saying about 15% higher here. Gross margins, we're told, stay the same, but SG&A increases by 5% per year. Revenue falls at first, so our final margin here is probably a little bit lower than when we started. Taken all together, we can say that the year 5 revenue is probably around 80 million, which is up from the 68 or 69 million in the beginning. And then we can say that we end up with around a 25% margin, so an EBITDA of 20 million, which is slightly lower than the 26% margin when we went into this. So now we have our final year EBITDA, we know the final amount of debt outstanding, and based on that, we can get to an approximate IRR. We know that we should be using 6x for the exit multiple, so the exit enterprise value here is 120 million. Now, for the exit proceeds to equity investors, it's 120 minus 40. That gives us 80 million. We made a very rough assumption for the amount of debt outstanding and said 40 million, which leaves us with 80 million for the equity investors. Now, for the rollover equity, we know that the management team owns 20%, the PE investors own around 80%, so they get back around 64 million of the 80 million in proceeds to equity investors at the end. Now, in the beginning, they contributed 25 million. They get back 64 million at the end, which comes out to a 2.5x multiple. Now, this doesn't officially fall into any of the rules that we had in the beginning, but the way to think about it is that we're halfway in between doubling and tripling our money. So the IRR is halfway in between 15% and 25. And actually 64 divided by 25 is more like a 2.6x multiple, or is just over 2.5x. So we would say the approximate IRR here is just over 20% because the multiple is just over 2.5x over 5 years. The final conclusion here is that we'll probably lean toward a yes in this recommendation and make sure our model supports it because of this quick math we did. And of course, at this point, we would go in and actually flesh out the model over 3 hours or 3.5 hours. But it really helps to take a few minutes in advance to see which direction we should be going in here, and also to set this up so we can check our work in the end. That's it for this tutorial. To recap what we did, the rules and rules of thumb for IRR are pretty simple. For doubling your money scenarios, take 100%, divide by the number of years in the period, and then make the IRR about 75 to 80% of that to approximate it. And keep in mind the rules for doubling and tripling your money over 3 years and 5 years. If you double your money in 3 years, that's a 25% IRR. If it takes 5 years, it's a 15% IRR. If you triple your money in 5 years, it's a 25% IRR. Then you learned how to apply the rules to a simple LBO model, and you saw how you could check your work before beginning a modeling exercise. And then I showed you how to apply these rules to a real life scenario and make some very quick estimates to take 5 minutes to check yourself before you begin spending 3 or 3.5 hours on a case study, so you know what type of recommendation you should be leaning toward, and so you can also check your work when you get to the end of that exercise.